Hello, everyone. Welcome to the second week of Vibecoding with Waku, the communications component of the Logos technology stack. Today, with us, we have our Logos interns, Katija, Lewis, and Dotun, and we'll be having a quick presentation from Katija to start today's live stream about Logos technology as a whole. And then we will be having a live coding session with Dotun, where he'll be helping us understand Waku with a live demonstration of building a simple anonymous whistleblower app where you can anonymously post messages into the wall and you can pretty much stay private whilst whistleblowing. So, yeah, that's the agenda for today, and I'll let Katija take the stage. And we'll be going quick into the live coding component once that's done. Katija, do you want to share your screen and get started? Perfect.
Can you can you all see my screen?
Yep, we can.
Nice. And yeah, great. Hi, everybody. Can you also hear me?
Yeah, perfectly fine.
Okay. So, hi, everybody. My name is Khadija, and we'll be talking about decentralized privacy, governance, and the rights of networked societies. And before we do a quick dive into today's topic, um, we'll also be talking about, how decentralized privacy and governance is in relations to Farewell by Westphalia. It's a book written by Jared and Peter at Logos. So for those of you that didn't join the last time, my name is Khadija. I'm a developer relations engineer. I currently do my research. I'm currently a research scientist at Institute of Future at University of Nicosia, and I currently work at Logos as an intern, and we'll be discussing Farewell by Westphalia, like I just said. Uh, Dotun did an intro to logos. We also do um, I'll relate how the book goes, in line, with logos, and then we'll also talk about opportunities at logos. So I know that a lot of us understand what decentralized privacy and governance means, and it's also essential to note that when we're talking about decentralized privacy and governance, it means different things to different blockchains, right, and different ecosystem based on their value proposition and based on their consensus, right. And today I want to explore what decentralized privacy means in this new digital era and how these ideas ties into the book called Farewell to Westphalia, and finally how they connect to what we are building at Logos, including the upcoming hackathon that we are going to also be doing a workshop on today. So um, what does decentralized privacy mean? And also a little disclaimer before we go deep dive into um, today's topic concerning what we're going to talk about, but logos, decentralized privacy, just for you to know that this is my own personal, based on my personal research and my own understanding, right? If anyone has any questions going forward, you can let me know. So for me, right, what I always tell people is that decentralized privacy isn't just about protecting personal data. It's about reclaiming, agency. It means, creating systems where individuals or centralized authorities control their digital identity, communications, and the information they choose to share. Instead of trusting a single gatekeeper, people build trustless systems where transparency and encryption protect our rights by design. So, on the other hand, decentralized governance um, ask questions like, oh, how do we make collective decision without a central authority? So it's like the evolution from top down power to bottom up coordination, whether it's through a DAO, consensus mechanism, or open communities managing public digital goods. So these two ideas, privacy and governance, are sort of like laying the foundation for what some people call the cyber state or network state. So which means societies built not on borders but on shared values, cryptography and collaboration. So now so now this brings us to farewell to Westphalia. So farewell to Westphalia is a concept and book that I believe everyone or every serious researcher in political science, sociology, technology, and governance should engage with. So this book is not just for people in Web3 because it talks about so many things, that are very, very essential, right? I'm going to be sharing the link to the book on Amazon. So it talks about the Treaty of Westphalia in 1648, which sort of like gave us the framework for the modern nation state. So, and the modern nation state is like a system built on territorial sovereignty and central control. But when we look at the internet today, decentralized technologies have begun to erode those boundaries. We no longer live solely within physical borders. Our identities, economies, and collaborations, they transcend them. And Faber to Westphalia challenges us to rethink the foundation of statehood, governance, and collective organizations in the digital age. So for everyone, if you are a researcher, you're a PhD student, or someone that is very, very, interested in these things or in political, views, like this book is really essential because it provides the theoretical scaffolding for understanding how emerging technologies like blockchain, AI, and open networks are transforming not just markets, but the very structure of authority and citizenship. And this book is so interesting because I mean, I'm not done reading the book, right? But like while reading the book, right, it pushes us to ask questions like, what happens when digital communities begin to act like nations? Who protects, digital public goods when government cannot? And how do we safeguard, privacy, freedom, and culture in a borderless world? And these are not like abstract, questions. They are the intellectual foundation for real technologies and systems being built today. So, and that's where, logos play comes into play. So, I'm sure most people that didn't join during the last live stream, right? Logos represent a movement and a technology, stack committed to creating open system that safeguards privacy, civil liberties, and access to knowledge. So it embodies the theories presented in this book, The Farewell to Westphalia, transforming them into actionable practice. Um, and Logos sort of like harnesses the principles of distributed governance by employing open source infrastructures, peer-to-peer communication, and tools that prioritizes privacy. So Logos operates on three guiding principles: freedom of association, which is the right to organize and build freely online; privacy as public goods, which is ensuring confidentiality and dignity in communication; and lastly, open access to knowledge and culture. So our collective heritage remain free and preserved for all. And in conclusion, right? So if Farewell to Westphalia is the theory, Logos is the living laboratory um, that that comes next for like digital governance. So the book sort of like lays that foundation, and then Logos is where everything is being done practically, and this is why and that is how Logos decided to like build three components, which is Waku, secure peer-to-peer messaging; Nomos, consensus and governance framework; and Codex, decentralized storage. Each layer is modular but work together as a full ecosystem. So if you understood what I've been saying from the book, you will understand like where Logos is coming from, right? They picked everything that's happened or everything being said in the book and decided to like let us build three different components that represent each of these, privacy, governance, and so many other things. And to translate this philosophy into action, that is why we are collaborating with Tor and the Internet of Archive to host like this hackathon, with funding the commons, where everyone can build like different decentralized products together. So we'll talk more about it with the use cases going forward after Dotun does his workshop because of time. And yeah, that's it. Thank you very much, everyone.
That's amazing. Thanks for giving us a quick overview about logos. And I would also like to take this opportunity to give a quick shout out about the Real Fi Hackathon, the one that Khadija mentioned, along with funding the commons. The hackathon is already live, spanning from September 23rd to October 16th. And we have two different tracks for the hackathon. The first track is the Resilient Activities track, which has a bounty of $4,000, which can be split between one or two winning teams. And a key card hardware wallet will also be provided to each member of the winning team. And we also have the collaborated track, which is the logos uh, and Tor track, which focuses on privacy infrastructure. We also have another $4,000 allocated towards this track, and this will be split between one or two winning teams. And each member of the team will also be getting a keycard hardware wallet. You can find more about these tracks with some example project ideas on this particular website linked on the QR code. We do have a lot of projects getting built already. So if you haven't registered for the hackathon, I would highly encourage you to check it out. And you can also find more about the bounties as I mentioned in the link provided. But just to give you a quick overview, the Resilient Activist Technology track is pretty much open to any idea that is revolving around resilient activism, like the one that recently took place in Nepal, where a community had their democracy and voting take place right in a Discord server. And something like status can easily replace a centralized hyperscaler like Discord. And this is exactly what we are looking for in this specific track. We want hackers to explore more ideas which can provide uh, or facilitate better democracy tooling. And the second idea or the second track is the privacy infrastructure. And this is pretty much open, where you can use logos and Tor to build your own infrastructure that can be used for building consumer apps. So, two great tracks for you to look out for. And you can find more about this in the link that was mentioned below. So yeah, we'll go ahead quickly to the next part of today's live stream, which is the live coding section, which will be hosted by Dotun, our logos intern. I'll give the stage to Dotun to get started. And also, we will be having a quick introduction about Waku and a quick look at the documentation before we go into the coding part. I'll let Dotun take the stage.
Hello everyone. My name is Dotun and I'm an intern at Logos. Also, as Guru said before, I talk about the project. We're just gonna go through the Waku documentation a little bit. So, as Khadija has said, she pretty much explained the Waku protocol easily, and I think I did too last week. If you missed it, you can always go back to watch it. So I'm just gonna explain like a little bit of the technical part today. So the Waku network is a shared P2P messaging network that's person to person, that is open access, useful for generalized messaging, privacy preserving, scalable and accessible, even to resource restricted devices. So the major features are DOS for spam protection with rate limiting lognifiers, scalability by sharding topics or traffic rather into eight pop sub topics, automatic shard selection, services for resource restricted nodes, and so much more. But those are the core um, features. So I'm not going to talk about this because we pretty much spoke about it last week. So, like I said before, Waku is a protocol that the communication layer of the logo stack, and it allows decentralized communication effectively. These are prerequisites if you want to run a Waku node on the Sabula testnet. And yes, you could just come here. I'm gonna paste the link for you in the comments so you can. So let's talk about the protocols. So like I said, it's a family of protocols and their concepts under each protocols. So yeah, so it takes a modular approach, provides a range of protocols that enable applications to control the trade-offs involved in the anonymity trilemma. Um, how do I explain that? Basically, it promotes anonymity in decentralization, not pseudonymity, which is the use of nicknames. So this is the first protocol, Relay. It employs a PubSub architecture to facilitate the sending and receiving of messages among peers. It extends the lib2p gossip hub protocol, basically. Then we have the rate limiting nullifiers. RLN relay protocol extends the relay protocol by using RLN to provide efficient and economic spam prevention. Then we have the filter protocol, which allows listeners to selectively subscribe to specific messages relayed by other peers using content topics. Then we have the store protocol for storing messages in relayed in the network. So if I send a message to someone, the store protocol is responsible for storing that message for retrieval or whatnot. Then we have light push. This is a protocol for nodes with limited bandwidth and short connection windows. Then Waku message specifies the structure and format of messages in the Waku network. So the Waku message has the content topic attribute for content based filtering. I'm going to talk about content topics here. Then we have the payload attributes containing the message data payload to be sent, the meta attribute for additional details, and timestamp for time, and the ephemeral attributes specifying whether the network should store or should not store the message. So these are content topics. They're basically string sets by developers on outgoing messages to facilitate protocol level features like selectively processing incoming messages and retrieving historical messages. So like I said before, the relay and filter are for processing messages, while store is for storing messages that meet specific criteria. So you can look at the Waku 2 topic here. The link is on your screen, so you could always check it out. So if you want to create a content topic, I'm gonna show a code sample for this later. So this is what it looks like. The name of your application. So for me, Whisperboard, the version. The content topic name is um, messages basically because it's just a Whisperboard taking messages and then displaying it on a larger screen. And so yeah, as you can see, application name, version, content topic name, and encoding. So the message is encoded with protocol buffers. That is proto, and so that's what will be here. It's proto that's going to be written here when you're writing your content topic. So amazing. This is an example of what it looks like for a private message. So this is the application name, the version, the channel, sorry, content topic name rather, and the encoding protocol. So these are just naming considerations. When choosing a content topic, it's essential to consider the privacy implication. So for example, these protocols, the filter, store, and light push, share content topics with peers, allowing them to link IP and content topic interests. The relay protocol using Gossip Hub provides recipient anonymity. So the recipient is anonymous and it can be compromised if the content topic exposes user information. So this practically says you should be conscious of you know how you name your content topics. So for example, instead of using identifiable information in the content topic, you can create buckets based on the first part. So Waku is developing a privacy preserving feature like anonymous filter subscription for the filter protocol and anonymous query for the store protocol. um, you can increase key anonymity within the network by using a unified content topic across the entire application or targeting specific features like notifications or private messages, allowing many users to share it. So it's also recommended you switch functionality using the proto buffer that I explained earlier, message format. By doing so, applications can retain a granularity and functionality while using a single content topic. So yes, that's what content topics are. Network domains are
Sorry
the
for
domains that
interrupting.
we have.
We do have two questions about content topics. So I think it's
Okay,
also a good idea to answer them right now before we move to the next topic. The first question is about the privacy of content topics. So, content topics are not private by default. A Waku as a network is public and open for anyone to look at. It's just anonymous, but any information shared as data messages through Waku are not private by default. And you can definitely make this private by using some kind of uh, encoding. Uh, and a good solution for this could be Taco, which is a part of Threshold Network. Taco is a access control uh, SDK that is easily integratable with Waku, and we do have an example app built with them already. So yeah, that's probably the answer for building private content topics. But anyone who has a content topic can pretty much see what messages are moving inside the content topic. And the second question is about the usage of multiple content topics within one application. And yeah, some applications may have a requirement where you need multiple content topics. For example, you can have a messages content topic, and there can also be a friend request content topic in terms of a social media app. So you can definitely have two different content topics, but the only deal breaker is to set up a filter subscription for both these content topics or handle it dynamically. So yeah, uh, that's probably in the hands of a developer who is utilizing it. But yeah, you can definitely use multiple content topics, like Dotun mentioned earlier. You have a categories field where you can pretty much follow the standard to uh, have multiple content topics within the application.
Right. Thank you so much, Guru, for answering that. Just to add to what he said, you could have plenty content topics. It majorly depends on what you're building. So for me, for example, the Whisperbot did not need a lot of content topics, just need one, but it depends on whatever application you're building. So back to learning. So Waku is a unified and cohesive entity that offers a rich ecosystem with three network interaction domains. And these domains are discovery domain, gossip domain, and request or response domain. So peer discovery in Waku facilitates locating other nodes within the network. So as a modular protocol, like we've always said, Waku uses various discovery mechanisms such as disk, V5, and peer exchange. This allow you to choose the most suitable options for any specific use case and user environment, including phones, desktop browsers, servers, etc. And then we have the Gossip Hub or Gossip Sub rather, derives its name from the pub sub networks where peers gossip about the messages they've encountered, thus establishing a delivery network for the messages. And they use RLN relay, the relay protocol basically across the network. That is what Waku uses. Then we have the request response domain. So Waku has the store, filter, and light push protocols to enable retrieval of historical messages, efficiently retrieve a subset of messages to reduce bandwidth usage, which is cost effective, and facilitates message publication for nodes with limited bandwidth and short connection windows. So if you want to read more, which I recommend you do if you're building for the hackathon or generally, reading here would be awesome because it's really, really packed. So transport is just practically how data packets are moved across a network by establishing connections between peers. We define the rules and protocols to ensure efficient network transmission, routing, and data delivery. So by default, Waku uses the transfer communication protocol, which is TCP, and service nodes should employ TCP for listening to and connecting to other nodes. Then use the secure WebSocket in browsers to set up SSL certificates, enable incoming connections from browsers, and serve them securely. We also have WebRTC, Web Transport, QUIC, and they've been studied for potential integration. So duly notes that Waco ensures compatibility and improved communication capabilities by following these transports. So let's talk about peer discovery. So when you use a Waku node, for you to fully use the protocol, you have to connect to a peer, which I'm currently facing with my project. So when you're making the product and when you're initializing the node, it has to look for a peer to efficiently use the protocol or the protocols rather. So once the connection is established, the node must actively seek out peers to have for message features. For example, we have the relay mesh, store, light push, filter, etc., etc. So the goal is to have at least six pairs in the mesh. This ensures that there's a robust network where messages can be efficiently relayed. They also reserve pairs for backup. It's essential to have a surplus of pairs available as reserves. These reserves are backup when the current pair becomes overloaded or maybe just unexpected disconnections. Then there are some certain pairs with specific capabilities. So the Node 6 out pairs with capabilities like store, light push, or filter, or really whatever you really want to use in your application. So this can help with targeted interaction, and you won't have pairs that you're not using, basically. Waku supports configuring static peers, peer discovery via DNS, disk V5, ambient peer discovery, and peer exchange. Uh, so static peers are static peers. Waku applications have the flexibility to embed Bootstrap node addresses directly into their code base. So you can either use static peers operated by Status, which is an app by the Logos ecosystem, or you could run a node. So the pros of this are low latency, low resource requirements, which is cost effective and economic, but it is vulnerable to censorship. It's very limited in scalability, meaning you should not use it for large use cases, and maintenance challenges as well. So this is what the architecture looks like. Alice is connecting to Bob, and they have to connect through to a static peer, like, and the message goes like that. So this is just a simple P2P interaction using their node details, and this is hard coded into Alice's node. So which is why, of course, maintenance is hard, and this cannot really work when you're dealing with a lot of people. For example, a group chat kind of application. Then we have DNS discovery. DNS discovery allows the retrieval of ENR tree from the TXT field of a domain name. This approach enables the storage of essential nodes, including IP, port, and multi other. The pros are low latency, low resource requirement, economic as well, easy bootstrap, and ability to reference a larger list of nodes than static peers. So the cons are it's also vulnerable to censorship. Domain names can be blocked or restricted, and is also limited for scalability. But of course, better than static peers. This is what the architecture looks like. Uh, so I think if I decide to explain each and every architecture, it might take more time. So I'll just recommend you look through it. So if you do not understand this diagram, you could just read it down here. This explains what is happening in the diagram, and then you can refer to this for more explanation. Then we have disk V5, decentralized and efficient mechanism for the network. It uses a distributed hash table for storing ENR records, providing resistance to censorship. It offers a global view of participating nodes, enabling random sampling for load distribution. The pros are continuously researched and improved, and is decentralized with random sampling. So you're coming from a global perspective. Cons, it requires a lot of connection and relies on UDP, which is not supported in web browsers. So this is more complex, as you can see. Uh, it makes use of the static and the DNS um, what's the name? The DNS peer discovery method as well. So it's like a combination of both with extra features. So, like I said, if you do not understand the diagram, you could read this to understand how it works. Then we have peer exchange. So, primary objective of this is to facilitate peer connectivity for devices without relying on disk V5, which is not very compatible with browsers. So the peer exchange protocol enables light nodes to request peers from other nodes within the network. So the pros is cost effective, it's decentralized. While the con is it is not totally anonymous and imposes additional load on responder nodes. As you can see, it also takes some from the static peers and DNS discovery type of discovery. So security features of Waku pseudonymity, which is the use of nicknames instead of your name. So that is a PID as an identifier instead of disclosing your true identity. Then we have anonymity, which is completely anonymous. You cannot connect to the actor. You cannot connect the actor to the actions or data, basically. So the features that we have in Waku are publisher message on linkability and subscribe topic on linkability. So subscriber topics in the relay protocol cannot be linked to topics they've not subscribed to. So in the content topic that we have before, if you do not subscribe to a certain topic in whatever application you're building, maybe a group chat, and someone is subscribed to messages, they cannot access what is in payload or any other thing, basically. Then we have spam protection. There's a spam protection feature in the relay protocol that ensures nobody can flood the system with many messages, regardless of the validity or usefulness. This protection is achieved through scoring mechanism of gossip sub version 1.1. There's also data confidentiality, integrity, and authenticity. And in protocols like store and filter, where we have direct connections, Anonymity or linkability is not guaranteed because the node used PID to communicate, basically to identify which is which and where to go. So in store, the query node can link the query node's PID to the topics being queried. Similarly, in filter, a node can link the PID of a light node to the content filter. So these are experimental features: economic spam resistance, prevention of DOS and node incentivization, research resources in case you want to look through, and research papers as well on rate limited nullifiers, message latency, modular P2P protocols of Waku, and the Waku network as infrastructure for DApps. So it's a pretty long page, but we're not going to talk about research because we'll keep talking on and on. So this compares Waku and lib2p. So Waku was built on top of lib2p. If you read the article the Guru shared, you probably understand what I mean. So they share a lot of concepts and terminologies between them. However, there are key differences that are worth noting. Now, Waku is a service network. It intends to incentivize mechanisms to run nodes, but it's not part of the lib2p scope. Additionally, users or developers now have to deploy their infrastructure as a prerequisite to use Waku. Waku also includes various protocols covering privacy, censorship, platform agnosticism, allowing you to run on any platform or any environment. And lib2p does not have economic spam protection. So glossary is just um, definitions of certain words, which I think I've explained almost all, but you could always refer to it and you can check the frequently asked questions that we have. Thank you very much. So now I'm going to move to the project, which we're still debugging, by the way. Uh, okay, so this is what our Whisper board looks like. It's connecting to the Waku network, but it most likely won't because I figured I've been using the older version of the protocol. Oh, sorry, the SDK. I was using the version 19 and Waku is currently on 35. So I'm trying to update that, but I've not pushed it to the GitHub yet, which might take a while because I think I need to correct some deprecated things as well. So practically, the app is a whisper board. I felt like it was going to explain Waku brilliantly because it's basically a large group chat where anybody anywhere sends a when anybody anywhere sends a message. As you can see, once you send the message, it's gonna pop in here like a rectangle, and it's gonna have the time that it came in, and it's not gonna have who sent it from anywhere. So and which is not traceable as well. So I thought that was gonna explain the features of Waku really, really brilliantly. So it's a decentralized message board app that uses the protocol to allow users to send and receive messages in a censorship resistant and privacy focused way. So I built it with React for front end and Waku for peer to peer messaging. Let me drop the GitHub link so that I can check. At first, I wanted to build a tic tac toe game, but I realized that Guru actually built that a while back. So I didn't want to repeat the idea. So you might see some files that are not necessary because I just converted the tic tac toe game to the Whisper board. Okay. All right. So I'm gonna
All
drop
right.
the.
Sorry for interrupting again, but I also wanted to give a quick shout out for the hackathon once again for people who joined us in the last few minutes. We have a hackathon ongoing with funding the commons. We have bounties worth $8,000 up for grabs. And yeah, this is also probably a good time for us to discuss ideas. Do you guys have a favorite idea that you would like to see built in this hackathon? I feel like this project itself is a very cool submission for the hackathon because this can be used as a whistleblowing tool without actually exposing your identity. Imagine you find out something about a particular politician in your country and you wish to expose this in public without compromising on your privacy. I feel like Whisperboard can help you do this already in a censorship resistant way. And yeah, this is a very cool idea that I can already think of. But do you guys have any other ideas that you would like to see implemented in this hackathon? The question is also open for Lewis and Khadija. Do you guys have anything that you would like to see personally?
Okay, I thought Louis was going first. That's why I didn't unmute my mic. So I think for me, um, uh, let me see. I think I mentioned some projects the last time, right? I I I would say like what Dotun built to is also really cool. Um, I don't know if you guys know this, anonymous message thing that people do where they post out a link and then people write stuff about them. Yeah, I feel like, someone can do that, even better. It's always fun when people do that because I know the current one now, if you pay for premium version, you can actually see the people that sent those messages. But
Yeah, that's funny because I actually checked this out. There was this thing called ngl.link, I believe, and it was
yes, NGL, yes.
yes, Instagram thing where you put out
Yeah,
a link.
yes,
Tried it,
yeah,
and the best
yeah.
part is after I put out anonymous feedback or anonymous question to someone, I just found out that they can pay a premium and then get to know
Yes.
one who
So
do.
they just pay them to, tell me who wrote this message, and then you pay the owner of the app, and then it releases your information to the person.
Exactly. And that is definitely super unethical because they don't even let you know about
Yes.
this beforehand. Like,
I mean, and the thing is that the whole point of the application of the website is to stay anonymous. So why do you have to let people pay to reveal their identity? Like it just doesn't, like you said, it's not ethical. It doesn't make any sense. So yeah,
yeah.
that's it.
And also, I have another unique reason why this should exist in Waku because Waku has a unique feature which is rate limiting, decentralized, and anonymous rate limiting, which is probably first of its kind in any decentralized network. And we use something called RLN, rate limiting nullifiers, just like Toten mentioned earlier. And this was a research initiative from Privacy Scaling Explorations, a part of Ethereum Foundation. And it's pretty cool because you can simply generate a RLN membership and then use that as a proof to use that to generate a proof to kind of protect the network from spam. So people can't simply bombard your network with uh, spam messages. So this is also a very unique use case because I know with NGL you can submit as many as uh, confessions that you want, and this can potentially also cause disruption to a network if it's decentralized. So yeah, RLN can also be a very
And also cause disruption to the person's mental health too by writing
exactly, yeah.
by writing bad reviews to the person.
Yeah,
So you disrupt the internet and then you disrupt the person's mental health.
yep.
Cool.
Lewis, do you have an idea from your side that you would like
Yes,
to share?
yes, of course. So I was thinking of an idea for this hackathon that is more easily to implement and also more friendly related with the use case, but think in a feedback form, for example. So typically we have the Google Forms, for example, or type forms. So in the most of the cases, these forms ask you for your email. So why and foreign is asking me for my emails just to send feedback. So behind the scenes, the email is used to some marketing things, but imagine a form, for example, using Waku to send the feedback to the network, and you know don't use your email. You only going to use a private key, public key that Waku uses to send your message to the network. So this basically a privacy form keep the privacy of the people, the users. So that's my idea for this hackathon is I was or I was participating in the hackathon, for example. So this one of the ideas that Waku team and Logos team want to see during the hackathon and the project submission. So yeah,
Mhm.
go ahead.
I think that's cool because all the events that you have during DEF CON, a lot of events, not every event, most of them use Luma for their event registrations, which is also a form, and there's no guarantees for the form to be private or even decentralized. I don't think Luma has a decentralized application anyway. And worst of all, some people even use Google Forms. I mean, even honestly speaking, even I use Google Forms in today's world just so that people find it easier to submit, uh, you know, submit a survey or any kind of response or even feedback gathering. So I feel like there's a huge potential for something built with Waku. And I know Fileverse is one of the projects who might already be building this. I just heard this alpha from a couple of people. So yeah, this is really cool uh, to have something built with Waku for feedback gathering or any kind of response
Yes.
gathering. And yeah, just before I let Dotun take the stage again, I would also like to share a couple of resources. The first one being the Waku Community Curated Project Idea Board. You can find this at ideaswaku.org. And we have around 50 or 60 community curated ideas from the last 2 years. So yeah, feel free to check this out if you're looking for some inspiration to build on top of Waku for the hackathon specifically. And also, there's another amazing resource that you should be checking out if you're interested to participate in the hackathon, which is the awesome Waku repository. This has a collection of previously built projects at different hackathons. We have more than 100 projects listed over here, which also includes projects from the Waku core contributors itself. We have Vaslav, who has been building a lot of projects with Waku over the last couple of months. Kwaku is one of my favorite projects, which is question and answers over Waku. That's Kwaku, and that can easily be coupled with something like this live stream where people can ask their questions using Kwaku, so that we can't really find out who is the one who actually asked the question. So it's just a matter of rebuilding the core Waku part. You can simply replace the Q&A part with something like a form, which can easily help you build a Google form alternative that is decentralized. And you also have a handful of workshops available in this repository. So yeah, an excellent resource if you're trying to learn more about Waku. Now I'll let Dotun take the stage again, but again, we have 8,000 in bounties for grabs. So make sure to stay focused on the next couple of minutes where Dotun will be helping you understand the Waco implementation. I'm sure there's also a couple of bugs that he is facing right now. We'll try to get these bugs fixed in this live stream. But if not, we'll be making sure that the repository gets updated after the live stream.
Right. Thank you, Guru. I'm feeling very motivated to participate in the hackathon because I like money, I think. So yes, so I changed it from the UI to the code so I can explain, the behind the scenes of the Whisper bot. So let me just walk you through the application flow before we look at the code. So when a user enters, the app initializes a light node. That's a lightweight peer in the Waku network, and this looks for peers as defined in the config file, which I'm going to show you. It waits for Waku protocols. Like I said before, it's going to look for peers that can handle light push, filter, and store. So when it's available, it's going to connect and it's going to reflect at the top the number of the file that it is connected. So with that, the user will have access to send messages. So when the user sends a message and presses send, the message is sent through Light Push protocol to the Waku network on the message content topic, which is the only content topic I have for the app. So the app subscribes subscribes to the same topic using the filter protocol to receive new and real-time messages. So it displays the time the message came in, so it fetches old messages as well with store protocol. So that's it. The three key files are, they're actually just three: the Waku config.js file here, and the Waku service file, and the UI is displayed here, Whisperboard. So all of this are really unnecessary. Like I said, I was building a tic-tac-toe game before, but I changed my mind like 2 days ago. So this is where it is important from Waku to create lights node to create a lights instance, then wait for remote peer and to import protocols. So this is the function. It's an async function because it's going to, it's a promise type of interaction. So it's going to try. If you come to my Whisper board, you're going to see Waku node that started. Sorry, initializing Waku nodes rather, and then to create the node, start it, then wait for the peers with these features: light push, filter, and store. And confirm if it's initialized, confirm if it's connected, to check how much pairs are available. And I also log that to the console. So you see how many pairs you're connected to, and then to start monitoring. And this is just the catch statement to catch errors. So if it failed and stuff like that. So as you can see, our file was loading, which means we're still looking for pairs. But like I said, I did not update the SDK. I'm using a very old version. So I'm going to update that. I'm actually updating it right now. So yes. So then this is the function to send messages. So this is the content the argument is going to receive. You check if it's initialized and the node, and then it's going to try this. As you can see, the content topic is messages, like I said before. And then the result, if the result is okay to send it, if not, fail to send message. And then this is just the catch. Then the message to see live messages, the function to see live messages is this async listen message. If it fails to subscribe, it's going to do that. It's going to send bug to the console or display it on the screen. It's actually going to display it on the screen. I think I rendered that in the front end. And yes, this is for fetching old messages. That's going to show as a list on the UI. And this is for monitoring peer connection status. I'm actually working on the README to explain in detail everything you need. So I'm going to add that. So this is pretty much the single instance that controls all services for the Waku node integration. So this is our config file where we have our content topic, the default bootstrap, and every other thing. So this is a specific node that I got from Louis. I've changed it in the code now to just use any available one. And so this is the connection timeout, reconnects delay, and peer stabilization. Then this is the content topics. As we had before, the name of my application, the version, which is one, and the content topic, which is message. And this is my encoding proto. So the same thing, channel, then routing, to monitor L checks, the protocol timeout, and that's it. So this is the get content topic that we're using in the services file, get channel topic, which I did not use, and to check if it has bootstrap here. So these functions are practically what we're using in the services file. So if you come to the front end, that is where it's just one single file and a lot of lines. So yes, initializing the Waku node, fetching historical messages with the function, the fetch history function from the Waku services file. Subscribe to messages, the listen messages function. Then of course our error checking, and then that's it. This is a cleanup function. This handles this message sending. So it tries to see if the message sends, and of course catches the error if there are none. And this is just the front end. We have a simple nav bar, a simple header here, and we have the message area where if it's not connected, if it's loading, it's gonna show connect to Waku network and establishing peer connections. And we have the parts, the input area where you send your messages. So that's pretty much it. Very simple project, 3 files, and you have your Whisperboard up and running. I'm actually going to start the project from scratch again and use the latest SDK, but I'm still going to push it to the same repository. Uh, I'm going to drop it in the comments for you so you could always, fork it and improve it with ideas like from Khadija. You can use it to make not gonna lie, NGL rather type of application, and many other types of applications. So, are there any questions on the project, or maybe help on the bug I'm facing, which I think I've pretty much solved? Okay, I think there's no question. Okay, so that's my little product demo. Thank you for listening to me talk for a long time. Any questions about the Waku protocol, um, protocols, or the Whisper bot? So Guru and I could answer, or any Khadija and Luis.
We don't have any questions from the audience yet, but
Okay.
I would still love to hear some about something about the light push filter and store protocol. Just before we start, if you can give a quick walkthrough of the purpose of each of these protocols, I think it'll be a lot easier for the audience to understand the purpose of this, because Waku is a family of protocols. Waku is not just one protocol by itself. It's a collection of multiple protocols, and each of these protocols have uh, RFCs which back the protocol, and a light push, filter, and store are usually considered to be the light protocols because they are capable of working in a resource restricted environment like a browser. And we are
Yes.
building a React app over here. So yeah, they are pretty flexible. You can also build native applications down the line, although JS Waku is currently not supported for React Native yet, but you can still find ways. I know people who have already built mobile applications with the SDK. So it's not impossible. Uh, it's just a matter of time to get it to work. But yeah, Dotun, do you wanna give a quick
Okay.
walk about? I
Okay.
can also share a visual just so that we
Okay.
have
Yeah. Yeah. That would be awesome, actually.
perfect. The visual is
Right.
on the.
So, okay. So the let me talk about filter. So the filter protocol is it allows nodes to selectively subscribe to specific messages with content topics. So for example, let's use my application for example. We have the messages channel. Let's say I now created a global channel, gossip channel, and social channel. So filter helps reduce bandwidth usage, but of course it has fewer privacy guarantees, but it helps reduce bandwidth by letting you look at just what you've subscribed to practically. So store protocol is for storing messages. So through light push is sent, store protocol stores that message for retrieval from the third party, which is the peer, and you. So practically between you and the peer. So it stores messages in a relay network, and it's possible for you to query and retrieve it later. It benefits offline peers the most, allowing you to see messages that you missed upon reconnection. Although using both filter and store is recommended when the node is online, because it does not guarantee data availability. The store protocol, I mean. So it's very suitable for retrieving messages when connected to the network. Like when, for example, when I load my Whisper bot, Store is going to retrieve the whole old messages. So light push is the request and the response protocol. So it allows you to receive a message and acknowledgement when sending messages. The lets you know that I sent, at least one peer has received it. Subsequently, it forwards this to the relay network and, you know, lets you know. So it basically acknowledges the receipt by the peer. So yes, those are the three main things that are involved in sending messages and like the whole flow from light push to store to filter. So those are basically um, each of the uses, basically. Guru, would you like me to add something specific or maybe talk about another part of the protocols?
Yeah, I can just simplify this a bit. I feel
Okay.
like the simplest example that I can give for this is, if you have, we already have a visual on the screen. Maybe you're not able to see it because your screen is getting shared. But yeah, I think just explaining the visual here.
I could see the visual actually.
Oh, perfect.
The message,
Yeah.
light push content topic. Yeah.
So yeah, again, I also wanted to kind of reiterate that Waku is not a messaging protocol. Messaging is just a unique use case of Waku. Waku is a general purpose communications protocol which can be used for sending any kind of data, but data sizes that are smaller. So you can't send a data size of more than, let's say, 1 MB. Imagine you're trying to send a data set of size 1 GB with Waku. That's simply not possible. But you can use something like IPFS or codecs for storing this data, generate a CID, and you can use the CID as the data that you are trying to transfer with Waku. And the one that you see on the left, the message icon, is the data that we're trying to send. And this data can be sent into a content topic, which is a partition or a namespace into Waku by using the light push protocol. So light push is for sending a data into a content topic, and on the other side, there's filter, which is for subscribing to a content topic. So when a particular peer subscribes to a content topic, uh, the peer will be able to listen for real-time messages or data that come into the content topic. We just use the word messages in a very formal nomenclature, but what messages means here is just any kind of data. But yeah, light push for sending data into content topic, filter for receiving data from a content topic, and store is just a caching layer. Imagine if Dotun sends a post into his, or maybe what do you call it? Is it a post in the board? Uh, what do you address a specific uh, part of the board as? Do you call it a
Piece of
post?
code, a part of the code, a specific part of the code.
No, the code. I mean, in your app, I know you're building a board. So, what if I try to submit a message into it? What do you call the particular message as? Or we can just not call it. We
Just
can just call it.
messages.
Yeah, we can just call it post for this reason. Yeah, imagine Dotun tries to post something into the board, and I'm not actively looking at the board right now. That's exactly where store protocol can be used. Store protocol can give you some persistence. So even if I'm not listening to the board real time, I can just simply come back to the board later to see that the post is available on the board. So yeah, it's just a simple caching layer, but also do not use this as an IPFS alternative. Store is just for temporary persistence. There are no storage guarantees for store. If you want storage guarantees, you should look at other decentralized storage networks. But yes, again, summarizing, light push is for sending data into a content topic, filter is for receiving data from a
Sorry for
content topic,
receiving.
and store is for temporary persistence. All right, back to you for.
So yeah, so I'll just work on the whisper board, update it, hopefully in the next couple hours. So if perhaps you see some sort of error or whatsoever, you could just leave a comment for me and I'm gonna check it out. Thank you so much for staying with us this far. Thank you. So Guru, the floor is yours.
Yeah, I can also quickly show some of the code snippets on the documentation just to explain how we implement light push, filter, and store in an actual application using the JavaScript SDK. I'm quickly going to share my screen and showcase the code snippets. I hope my screen is visible. Yeah, it is. So yeah, once you go into the documentation site, you can see the start building button and run a node button. So I can also give a quick intro about the run a node part. We have a video tutorial for you to follow if you wish to run a nvaku node. Nvaku is basically the full node implementation of a Waku, which cannot run in resource restricted environments like a browser or a mobile phone, but is used for relay servers or even cloud servers that have some resource to run the Waku full node. And yeah, you can follow the video tutorial, or also you can use the Docker container by using the Docker compose command. Uh, so it's pretty straightforward. All you have to do is to run this particular command, and it will help you configure a local nvaku node in your machine. But for today's building on Waku part, we have the JavaScript SDK, and we do have some video tutorials again here if you wish to learn more about uh, specific use cases being built on Waku. But yeah, to get started, you can use any kind of JavaScript based framework, and you can go ahead and install the Waku SDK, which is at waku/SDK, or you can also import it as a package. And once you do that, you will also be required to install protobuf, which is an encoding library that we use for uh, kind of templating the messages, and we'll see that in the next part. So yeah, two libraries that are important for you to get started. And once you have these two libraries installed, you can go ahead with the next section of the guide, which is sending and receiving messages using a reliable channel. Or we also have sending and receiving messages using light push and filter. We'll be looking at light push and filter because I believe Dotun was focusing on this part, and most of the examples are also using this method. So yeah, you can go ahead with creating a light node. For this, all you have to do is to import the create light node function from the SDK, and pass in this particular argument into the function, which is set default bootstrap to true, which uses the default bootstrap fleet that is already configured by us for your application. You can also choose to use your own fleet, like Doton did. We did have a custom node defined in the code base, I believe. So yeah, but in this case, you can simply use default bootstrap. But also, if you have issues using default bootstrap, you can reach out to us in Discord, just so that you can see if there are any ongoing issues with the bootstrap fleet. So yeah, once that is done, you have your create light node function completed, and then you can simply go ahead with node.start, which starts the light node. And after that, there's also other configurations that you can do. For example, when you create a light node, you can also initialize the content topic or pass in a network configuration for a specific cluster ID. So yeah, you can go a bit deeper into this in the docs. But yeah, this function is pretty much used for creating a light node uh, in your application. And once that is done, you can go for the peer discovery part, where you just have to call this function called wait for peers along with the node that you previously created. And this will help you identify or discover peers and connect to them. So yeah, this will help you with a successful peer connection. Or alternatively, if you want to connect to peers that support specific protocols, you can also pass in the protocols over here, like we do over here. We pass in protocols.lightpush and protocols.filter. So we will only be connected to peers that have these protocols enabled. Uh, so if you want to connect to peers that also have store protocol enabled, you should also be adding store over here. So yeah, a great way to connect to peers that support store protocol. And once that is done and the peers are connected, you can go ahead and define your content topic. Simply define the content topic in the format that was discussed earlier. Make sure to follow the template for the definition. And after you do that, we will be required to set up encoders and decoders. And this is where we have the create encoder function that comes in handy. You just pass in the content topic uh, inside the create encoder function, and similarly in the create decoder function, pass in the content topic. And another cool attribute that we have here is the ephemeral, which is set to true in this case. So Waku is by default not ephemeral, uh, uh, means that Waku messages are not stored or persisted uh, across the network. And when you use this particular property, you can make the Waku messages to be ephemeral, or you can also opt it to be non-ephemeral, which is simply using the store protocol for providing some persistence. So yeah, that's pretty much with the encoder and decoder. It's very simple. For a simple implementation without store, you can simply go ahead with this one. But if you want to use store, you should pass in the ephemeral property. With that, you have the Waku part completely set up. Now it's all about structuring the message and sending the message into Waku. So for this, you will have multiple options to encode messages, but in our case, you can see that we used protobuf as the type of encoding over here in the content topic definition. So we will be using protobuf library for templating the message. So import protobuf from the protobuf library and create a message data structure, which is pretty much similar to this, very straightforward. You can have multiple attributes for your message. In this case, this is a simple example that has a text message object. So there's a timestamp for each and every data packet. And there's also a sender, which can be a string in this case. If you want it to be an Ethereum address, you can also kind of use an Ethereum address instead of this. So timestamp, sender, and finally a message which holds your uh, actual message data. So this is how you template a payload by using protobuf definitions. And once you have the data packet defined using protobuf definitions, you are ready to send the message. So over here, you can see that this is the message object created with protobuf. And then we serialize the message by using the encoder that we made earlier. So just go on with data packet dot encode and pass in the created message object, and that should be it. You're all done with serializing the message, also templating the message, and all your uh, peer connections are already in place. So finally, we send the message by using node.lightpush.send along with the encoder and the payload. So this is all you need to send the message that is completely serialized and templated. So that's pretty much it for sending a message. But for receiving a message, you need to implement the filter or store protocol. It should be either one of it. So yeah, looking at filter, you can make a simple polling system which kind of polls the specific content topic for every few state changes or seconds, and then returns back the updated set of messages. So for this, you create a callback function, and in this callback function, you check if a payload is present in the message, and then you render the message object in the application. So again, very straightforward to do this, a very simple callback function. And then the filter subscription can be created by using node.filter.create subscription, and you pass in the content topic like we did for creating the encoders and decoders. So yeah, filter is also very straightforward. This is all you need to be implementing for receiving a message from a content topic. uh, and if you want to use store, that's when you use this particular guide, which is retrieving messages using store protocol. which is also pretty easy. All you have to do is to initialize the decoders like you did before, and the only difference over here is the query generator, or the way we call or retrieve the messages. So an example for this is over here. You can pretty much use the same query with ordered callback, which will give you an ordered retrieval of the messages from the store protocol. And you also have a query generator where you can uh, use the store queries to uh, query messages or data for a particular time period. For example, messages from yesterday, or messages from the last 24 hours, or yeah, something that is for a specific time frame. So yeah, that's pretty much it. We do have more uh, utility functions like encryption and decryption libraries built in within our SDK. But for the core concepts, light push, filter, and store, you all you have to do is to follow the two guides that are over here in the JavaScript SDK of the docs, and you will be able to build a simple solution within a matter of few minutes. And in regards to Dotun's issue today, this was more related to the uh, node initialization part, where we set default bootstrap to true. So sometimes we have issues with the default bootstrap fleet that we are running, but we did check about this and it seems to be working fine. So yeah, I think it's just a couple of tweaks that we need to get done before we get the application working. uh, but if you don't get it to work, the best solution is always to run your own Nwaku node and use this node as your bootstrap node. That way, it's more reliable for during the development phases. Yeah, that was my 5 or 10 minute non-stop rant about building with Waku. But we do have some questions, I believe. Oh, they're not questions. It's just some applause that we've been getting for today's live stream. But again, thanks for joining us today. Uh, just for the closing notes, we do have a hackathon running online with funding the commons. We have two bounties for logos. The first one being the Resilient Activist Technology track, where you can build anything that helps activists being politically resilient, or also organize governance, or uh, any sorts of use cases that require privacy. So yeah, that's a very open track, and you can learn more about the track in the following link. You also have some example use cases listed over there. And the second track is the logos and Tor collaborator track, which is regarding the privacy infrastructure. If you can build any infrastructure that can empower consumer applications that preserve privacy, this is going to be the track that you should be looking at. So yeah, two cool tracks for you to explore. And you can also check out the resources, the Waku project ideas in the ideas board. And we also have $8,000 in bounties, like I mentioned before. And finally, the awesome Waku repository. So that should be it for today's live stream. In next week's live stream, we will have uh, Lewis doing a presentation about logos, and also Katija will be uh, teaching us about Waku, and also guiding us about building a cool use case in the next week's live stream. So until then, stay tuned. Make sure to hit the follow button if you haven't. Join the Logos Codex, Waku, and Nomos Discords if you haven't already. So, yeah, that should be it for this week. We'll see you on the next Wednesday. See you guys.